In the previous PyFolding tutorial, we discussed how to load data into PyFolding using Jupyter notebooks and then to plot it to make sure that the data was correct. In this tutorial, we are going to go through how to fit PyFolding to some simple models where all the variables are not globally analysed over a number of data sets, but simply one data set is analysed at a time. So the first thing we'll do is open Jupyter Notebooks. So we're going to go to our PyFolding directory and look at the notebooks that we have already deposited, showing how to do a number of these tasks, such as fitting data. And what we'll do is we'll look at folding models 1 today. Now, as I said in my previous tutorial, which showed how to load and the format your data needs to be in and how to load it, each PyFolding notebook that we've deposited gives you background on what the notebook does, what data your protein has to, what format your data has to be in, and then provides the various lines of code that you require to run within the notebook to analyze your data. In the previous tutorial, we went through how this set of commands sets up PyFolding in the Jupyter notebook, how to load our data in .csv files, and to associate it with it being equilibrium or kinetic data. And then finally, how to plot it to make sure that everything is okay. So in this tutorial, we're going to continue and look at how to then take this data and fit it to the number of models that are already present in PyFolding. So the easiest way to explain this is I will open up another Jupyter notebook, a new one, and I will put the lines of code in that we require from the first models one to show you how each one does what it does, I guess. So first off, as always, we're going to input and start running PyFolding within this Jupyter notebook. We are then going to load in the data, which is FKBP12 equilibrium kinetic data, into the notebook. We're going to plot the data to make sure that the data is in and is functioning correctly. Remember to get any of the code to run, we must press Shift and return at the end of each cell. So both the equilibrium and the kinetic chevron datasets for FKBP12 are now loaded in. The equilibrium data is assigned to this name, and the kinetic data is assigned to this object. So, what models are part of PyFolding? Well, this set of commands here will first off import all the PyFolding models into this notebook, and then this command will list the models that are already present. So as you can see, we've got different types of chevrons, Ising models, 3-state chevrons, 2-state, so on and so forth. If we want to confirm exactly what the model is and what we're fitting, we can view that model and print it out with all the information by simply typing this command here, models 2-state info. So in this case, I'm looking and printing out the information about a two-state equilibrium model. And you can see that we get the equation for the model, what it is, the folding scheme that it relates to, the parameters of it, and the reference from where it was taken from. We can also use this command to discover in this model what are the parameters which will be fit. And in this one, it is the m value and the midpoint. So let's now try and fit the equilibrium data first. First off, we want to set the temperature at which the experiment was completed at. In this case, it was 25 degrees. We are then going to associate the model to a fit function, and then we're going to fit it. And here, this is our data. This tells it it's going to fit. We're going to fit it with this equation up here. And this is our initial values, where the m value comes first and our midpoint comes second. So as you can see, it's fitted this nice and quickly. And if we go to the full screen, so we don't squash it up, we can see we have our m value with its error, its 95% confidence level, our d50 again with its error, and finally the r squared coefficient of determination down here. So we can now plot the data again, but this time with the associated fit results by simply putting in the same command as we had further up in this notebook. And you can see a lovely fit from our data to the model. So we also loaded in the kinetics of this protein folding. And so let's try using the similar idea to what we've done with equilibrium to fit the kinetics. So the first thing we want to do is, if we look back up here, you can see the kinetics of FKBP12 pretty much look very two-state. So we want to use a two-state chevron to fit the data. And again, let's print out what a two-state chevron plot we can use. We can then show which of the variables we're fitting. And then, if we're happy with that, we can go ahead and start the fitting procedure. So first of all, we are going to associate our data, the kinetics of FKBP12, with a model and a fit function. We are then going to fit the data using this command here, and in the brackets we're going to put initial values for Kf. This is the refolding rate in water, Mf, Ku, which is the unfolding rate in water, and Mu. Again, we get really lovely fit results. The errors associated with them, the 95% confidence levels, and again, the r squared coefficient for determination. As before, we can fit the data. We fitted the data, we can plot the data, and as you can see, we get a lovely fit between our data and a two-state model, just like we have in the notebook. So we can also make a really lovely, pretty picture with both the kinetics and the equilibrium in one by simply using this command here, where this command tells it to do a lovely plot of the kinetics and the equilibrium. And in the brackets we tell it what equilibrium to use, what kinetics to use, and how to display it. And if we go full screen, you can see we've got a lovely figure to finish off the analysis with. We can change this command up here as per our notes down here by adding commands to this brackets. So if we wish to write out this whole figure as a PDF, we'd simply add a path of where we'd like to save the figure, the PDF, and tell it to do it. So let's redo the figure like this, and then if we go in, we can look, and you can see that I've now saved out a lovely PDF which you could use in manuscript. So now that we have fitted our data, outputted it in some lovely figures, the last thing I should really say to conclude this video tutorial is that if you do not wish to take the command lines from our Jupyter notebooks and make your own one, you can simply find the Jupyter notebook you wish to use, change the paths to your data. In this case, actually in the PyFolding directory, we have included a directory or folder called data, which you can put yours in, so you just have to change this folder here, and obviously where you put your data and what it's called. And then all you have to do is go to kernel, say restart and run all, and that will rerun the whole booklet from the beginning, replacing my data with your own without you having to copy and paste anything. So this concludes the tutorial on how to fit simple models to your data. In future tutorials, I will be looking at how you can fit more complicated data, say to global values over a number of data sets, and also show you how you can automate certain tasks like fitting your data to numerous models and saving your data, saving the fitting out to a .csv file, CSV file, in case you wish to make a lovely figure in different software, say Excel.